It's all or nothing, right?
Yeah. Sometimes I keep it. Let's do it. I know somebody else.
Okay. Advanced topics. Oh, forgot to give this to someone. This is your favorite class? Whose favorite class?
This is my favorite class.
Really? You guys just like math. Wrong book. You gotta get the right book. You gotta start with the right book. So guys, last time we leave off with we solved a rational equation. Not this. If we do alright guys. Chitter chatter.
I thought we did this one already.
That's what I'm asking. I'm trying to figure out where we are.
Oh, no, we
I
didn't.
teach other two classes. They're also advanced topics.
We didn't do this one.
Can someone do it? Since we probably did do it, and we're going to redo it.
Oh, I know.
I saw you raise your hand.
Does that mean it's recording?
Should be.
Oh, sure.
No. Is there something that we should maybe take care of from the very beginning that you may forget to take care of? No, it's okay. It's okay. Continue on. You're good. I was just curious. Least common denominator? Okay. What do you want to do with the least common denominator? All right, let me ask you this: what is the least common denominator? What is 3? Where do you see 3 as the denominator? Just so I understand it. Let me ask you this: what's the denominator of the fraction on the left-hand side of the equation? What's the numerator? X is the numerator. What's the denominator of that fraction? Ah, so that's one denominator of all of the fractions. What's the denominator of the next fraction? Okay, so they have the same denominator. And what's the denominator of the last guy, the guy with the very long tail? Okay, so we list them out in our head or on paper. We have x minus 3 is one denominator. Another one's got a denominator the same, x minus 3, and another one's got a denominator 1. Okay. So the least common denominator would have to be one that they can all be converted to. And so what do you think the LCD is? But is it easy to make x minus 3 through multiplication become 1? No, it's tough. It's tough. Be careful. I think it's very sensitive. Does anyone want to help? Be careful. Does anyone want to help out?
What you I think you could do, I think you can cancel out both the x minus 3's because they're both the same denominator. And then it becomes x equals 3 plus 9.
Yeah, you have part of it. You have part of it, yes.
You would it's 9 over 1, and then you make the denominator x minus 3 over.
Yeah, let's go ahead and do that. Let's make it 9 over 1. I like that. Let's make it 9 over 1. And you're saying let's make
The x minus 3. The 1 x minus 3.
okay, so you want all the fractions to have the same denominator, which is basically the one way to approach it. That's kind of the idea, yeah. Okay. You understand what she's saying? A little bit. She's saying change the denominator 1 to make it x minus 3. How would we do that? Yes. Through addition, through multiplication, through subtraction. Multiplication, okay. Mm-hmm. And then we gotta obey the rule. Whatever you do to the bottom of a fraction, you have to do to the top. Oh wait. What do you want to do? Do you want to? Because we're going down the direction. I thought we were going to change that 9 over 1 to something over x minus 3. Because there's more than one way to do this. There's more than one way to do this. So what do you want to do? Okay, so you want to convert that so that it's something over x minus 3? Okay, so I thought you were going to show, are you showing that you're going to multiply 1 by x minus 3? Then you also need to show that you're going to multiply the 9 by x minus 3. Because what is x minus 3 over x minus 3?
1.
It is 1. So you're just using the rule of the multiplicative identifier rule. Anything times 1 is itself. So this is still the same exact equation when you do that. You're just multiplying one of the terms by 1. It doesn't change the value of the term. So now we're going to have something written where all of the fractions have the same denominator. You don't have to distribute now. You can leave it in parentheses, x minus 3. In fact, that's a good idea. In fact, you guys might want to write this in your notes that leave things factored for as long as you can. That's generally a good idea. Leave things factored as long as you can. Okay. Anyone have any questions about where we are now with this equation? Any lack of uncertainty or understanding? Okay. Yes.
So she said like the same thing that the same, and instead of, so she just added that, like the x minus 3 with the 9, and then.
She did not add.
No, I'm saying like she just like multiplied it.
Okay.
So 9 is gonna be multiplied by 9. I meant by x minus 3.
She multiplied the top and the bottom by x minus 3.
Okay.
Why don't you just
It's not necessary until later. It's not necessary. It's usually easier to work with factored values than it is to distribute.
What is this called?
What is what called? This whole thing? This is called a rational equation in a single variable. This is actually, we've already done this problem, and this is in the textbook. Can you tell me, Sharon, what page number we are in the textbook? This problem is actually in the textbook, right where we are. It's at the bottom.
It's example 5, solving a rational equation.
Solving a rational equation. And what page is that?
107.
Page 107. So if you don't have a textbook, you might want to write what page number this is in, so you can refer to it. Okay, so we have.
What page was it?
107.
It's page 107. And you can actually write, if you don't mind, write that on the thing so that if you guys ever watch this video to review. Okay. All right, so look at the second line here. Everything is over x minus 3. Okay. What do you think you might want to do next? not really necessary right now. I mean, you could, but it's not necessary. What could you cancel out? What do you think? What do you, maybe, can you show me what you mean? It looks like you. When you say cancel, like, what does that become? Does it become 0? Does it become 1? All those things, values you crossed out, what do they become? Now, that's absolutely correct, what you have written. But do you understand why you are where you are now? Like, do you understand how those values all became 1 in the bottom?
Yes.
How?
There was, X minus 3 is, coming factor and all.
What operation did she technically do that she's not showing? But she did it, because I can see that she did it, but she's just not showing it. Yes?
Wouldn't it technically be multiplication since originally they're all being divided?
Yes, she's multiplying both sides of the equation by x minus 3. That's how that happened. I want you guys to know that why we can do what we can do. Does anyone not see that? Please let me know. You don't see it?
I see it, but how do you explain it? Yeah, like the way that you're saying it.
Okay. If you imagine that we put parentheses around this guy and multiply the entire left-hand side, which is just this guy, by x minus 3, and you could write x minus 3 over 1, you would see that x minus 3, because remember, when you multiply fractions, you can simplify diagonally when you multiply fractions. You can also simplify it directly up and down. Well, the x minus 3 and the x minus 3 would both go away to 1 and 1. So you'd have 1 times x over 1 times 1, which is just x. The entire right-hand side, if you imagine that there's a set of parentheses around the entire right-hand side, and you multiply the entire right-hand side by x minus 3, in a sense, x minus 3 over
So
1,
the top one,
and you distribute that to this guy, x minus 3 and the x minus 3 would simplify to 1 and 1, leaving you just 3. And the x minus 3 and the x minus 3 here would also simplify to, well, because you distributed to each, right?
Oh,
We're just not showing that. We're not showing that step. So there's a couple things that are not being shown that could be shown that would have you arrive at here. So there could be 2 more steps that we could show.
well, what about the top X minus?
Because you can only cancel diagonally or up and down.
Well,
It makes no sense to say x minus 3 times x minus 3 cancel. They don't, and it's not really canceling. They're going away to 1 and 1 because let's go back to
so it's just being replaced by a 1.
Thank you. Let's go back to the fundamental principle that I'm trying to point out here is this. Let's keep it very simple. If I had something like this,
Multiply B,
what is this? Simplify to.
A.
It's the same principle. So if I have something, let's say, for example, 2 over x minus 3 times x minus 3, what does this simplify to?
2.
That's what's going on here. She just didn't show the multiplication of each side by x minus 3.
Okay.
So do you see? And then because there's a plus here, there's an addition, you have to do the distributive property. So really, what we should probably write to maybe make things more clear is that this would when you guys say cancel, I think of 0, and that's not what this is doing. It's not canceling. It's just being reduced to 1, 1 and 1.
So cancel is just reduced to 1, actually.
Yeah, I wouldn't use the word cancel for this. When I think of canceling, I think of this. These cancel one another.
Oh, okay.
You know what I mean?
1 equals 0, then it's canceled.
Yeah, when I think about something added with something to make 0, that's what I think about exactly. That's what I cancel. This here is just if it showed the x minus 3, they would both simplify to 1 and 1. Just like here, you have this going on. This goes to 1, and this goes to 1, leaving you A.
Okay.
Alright, so this
So
would be,
technically, every letter is, like, every letter is one.
every letter is 1. What do you mean every letter?
Yeah.
So technically, that's
Like
1
one X
minus 3.
equals out.
You don't understand?
No. This whole x minus 3 becomes 1.
Oh.
That's
okay.
contained. That x minus 3, they're contained. They're
But what does
they're
X
stuck.
stand for, right?
X is just a variable, unknown quantity. We're trying to solve for it.
So we trying to figure out what it is.
Yes. X is X. X is X. We don't know what it equals yet, but we're going to solve it through manipulation to see X equals this.
Okay.
Can anyone go from here to complete this?
Yeah.
Please.
Oh, I have to go up and do it.
Oh, you don't have to. You can tell me if you don't want to come up here.
Distribute now,
Okay.
or do
Yes,
you-
and now at this point,
Are
yes.
you following Pentis or not?
At this point, I would distribute. Okay. Because I certainly don't want to divide the whole equation by 9, because then I'm just creating fractions, and I like to avoid fractions because I don't like to deal with fractions, and I'm assuming you guys don't like to deal with fractions.
Yeah,
We don't
I hate
have to.
fractions.
So let's go ahead and distribute. So if we distributed, what would we have if we distributed?
9x.
Well, first off, this is still x equals, this is still 3, okay?
Plus
Now here.
9x.
Uh-huh.
Plus 21.
Minus
7.
27.
27.
Yep. If you don't have a calculator, the 9s, you can go 1, 2, 3, put it down, and you have 27. You know the trick with the fingers.
Wow, never learned.
So 9 times 4, 1, 2, 3, 4, put down the index finger, you have 36. 9 times 4 is 36.
Where do you get 36?
Wait, how do you
Okay,
read?
This is a space.
Oh, okay.
This
okay, I
is
see.
separate the digits.
Okay, I wrote
If
it
you
down.
didn't have a calculator out, but you guys should have scientific calculators. Or I'll just pull them out when you get to class. So anyway. So from here, what's that? Oh, the fingers. All right. So from here, what do we do?
I had them.
Comment or like term.
Always, yes. Always combine like terms. Always simplify each side individually if you can. Do you see any like terms on the right-hand side?
Yes, 3 and 27.
The 3 and the negative 27, yeah. So
You would.
I'm running out of room here, so I know I can do a trick where I select it like this. Yeah, and then I can just kind of shrink it a little bit.
Look at you. Techie.
This thing still kills me though.
Oh, yeah.
Yeah. Okay, so x equals 3. What's 3 plus negative 27?
Negative 24.
9x plus negative 24 or minus 24, same thing.
Divide.
Ew, I don't want to divide. Not yet.
Subtract.
I will avoid fractions as long as I can.
Okay.
Subtract what? Subtract 9x
Yeah.
to each side.
So then it's 8x, and then x.
It's 8x.
Yeah.
Negative 10x.
Negative.
No.
It's negative 8x.
Negative 8x.
It is negative 8x.
And then
Negative 8x
divide by negative 8.
equals,
What it equals negative 3.
Divide by negative 8.
Oh, actually positive 3.
x equals 3.
I got it right.
If we, now what's one thing that we should always do if we have the time?
Go plug it back in.
Plug it back in, test your solution. So where's the original guy? Is that him right there?
Yeah.
Okay. Well, he's a little altered, so what I'm going to do, I'm going to go ahead and I'm just going to erase the part that's not originally part of it. Right, because the original guy was just this, right?
Yeah.
Okay, so let's plug in 3 together and see what we get. 3 divided by,
3 minus 3.
so which is 3 divided by,
No, wait, 0.
0.
Wait,
It is 0.
it is 0. What's 3 divided by 0?
Zero.
Wait,
Now
wait,
you're at
wait,
three.
what are you talking about? Why did you do that?
Why did I do that? Okay, I'm testing this. So I'm going to plug it back in. Because what does this say? This says x equals 3. So it should make this a true statement.
Okay.
Okay, so plugging it back in, what do we get?
3.
Over
3 minus
0,
3 over 0?
which is 0.
So 0 equals, 0 plus.
It's not a true.
So it's not equal.
Because they would equal 9 at the end.
If you divide the number by 0, it's 0.
It would be, yeah, but what about the 9? It says plus 9 and then 0 plus 9.
So I'm saying it's not true.
Then 0.
Or does it equal what?
It equals 0.
You have a calculator? Want to
Anything
plug in 3 divided by 0
divided
for
by
me?
0,
Anyone have a scientific calculator? It's part of your materials.
Definitely 0.
Anyone have a scientific calculator? Anyone
I have a
have a calculator
calculator.
that can help out a teacher and do 3 divided by 0?
I said error.
0.
Yours says error.
Are we going back to like?
Mine says
Yours says error
You
too.
can't do it?
Oh,
let me
so
check
it's
it out.
not-
Yeah, jump.
Oh, so you can't plug
I
it
don't
back in.
divide 3 by nothing. So it's wrong. So it's
It's
no
not
solution.
nothing. Remember, it's a number.
Divided by 0
this wrong.
is 0 is nothing.
Mine says, word.
3 divided by 0 is
Error.
undefined. Cannot do it. You cannot divide by 0 in math.
What?
It's the black hole.
Why?
Okay, what is 3 divided by 0? What do you think it is?
Okay.
Okay, so you think 3 divided by 0 is 0?
Yeah.
Okay. Do you agree that multiplication and division are inverses of one another?
Yeah, they're the opposites.
Okay, so let's do
You're
this.
taking away.
Let's do this. 6 divided by 3 is what?
2.
Why is it 2?
Because
Because
how
3
many
times 2 is
Because why?
you can get 2 3s out of 6.
Don't get mad. We'll get there. Why is 6 divided by 3 2?
Because 3 can go into 6 2 times.
Okay. So 3 divided by 0 is what?
0 because.
Because 0 times 0 is 3?
No, but listen to what I'm explain.
Go ahead.
0 can never go into 3. So it would be just 0.
0 can never go into 3.
You know what I'm saying? So it would be just plain 0.
But the thing is that 2 times 3 is definitely 6.
Yeah.
Yeah.
0 times 0 you're saying is 3. By the same principle.
0 times 0. What? Wait, you confused me. Wait,
He's
what?
like, no.
That's what you're saying. I said no. You asked me if you divided, and I said no. 3 divided by 0 is 0. Like because you can't.
No,
put it
it's
in.
like-
Okay, let's do this. What is 0 divided by 3?
0.
Correct.
3 can't go into 0.
0 times 3 is.
Zero.
Okay.
What about 3 times 0?
3 times 0 is 0. That's correct.
Then why can I say 3 divided by 0 is 0?
Because it's not defined.
Because like with the 6 over the 3, when you do that, you can take 2 3s out of 6. 3 times 3 is 6. You can't take any zeros. You can't take any zeros out of 3. So it's
So
undefined.
then why 0?
You can't.
Like remember that article that we read? It said 0 is like a doubly, like it should be divided.
Yes, it's infinitely even. Yeah, 0 divided by 3, 0 divided by 3 again is 0, 0 divided by 3 again.
Are you saying we can't
Do 0 divided by 3 and put 0 and then
like, oh, let's not
because
So
what
it's not
happens when
3
you
divided
put
by
0?
3, are they saying 0?
Do you have a calculator?
It's gonna say error.
0 divided by 3 is what?
Error. I put 0. I got
Oh,
0.
you put 0.
I cannot.
But I'm saying look, 3 divided by 0
It's undefined.
undefined.
How come when they say when you multiply from the back?
So if you divide them by 0, it's already 0. Then why is it?
You want me to show you graphically?
Because like 3
That's
is
not
If you're interested, I can do it show you
No, no,
graphically.
I don't want to waste time.
It's not a waste of
I
time,
believe
it's
you.
still mathematics.
I believe you.
like how come when it's like when you multiply 3 times 1 is 3?
Mm-hmm.
Then you add.
How come it isn't the same with the zero?
Wait, what are you saying?
Like, if you do 3 times 0, you get
Mm-hmm.
0 instead of
3 times 0 is 0, yeah?
Well, I
3
think,
times 0 is
I
0.
think what you're saying is like basically like if you do 3 times 1, you take 3 and do that once, you got 3. But if you take 3 and do that 0, you don't have anything, you get 0. If you didn't do it any time, you only did 0.
Just if you're struggling with it,
Yes.
because it's
It's not a big deal.
it's an interesting topic, but division by 0 is undefined.
Mhm.
Even this is undefined.
What about 0.0?
0.0 is 0.
It's still 0.
Now you might think I'm really messing with you if I told you this.
Oh my god. This is a really fun question.
It's not a 0. I don't know why you put a little head on the line.
2.9.
The line over it makes it go forever. That is
So
not.
9
Also, the little
but
thing
that's,
equals 1.
but that's right.
That's
the little, like-
round it up, if you round it up, it equals 3.
Yeah,
That's what it's
it equals
doing.
3.
Are you rounding or is the
rounding.
round equal 1?
2.99, that means 999.
Yeah, that means
So
Oh,
yeah,
yeah,
'cause
it's
it's
like a little, yeah, so that's just the shortcut to say it.
It's still,
Wait a minute, you
not
got me
3,
tripping for a minute. I was like, wait,
That's
oh
not
wait, no, that is right.
It's down 2.9.
It don't matter.
No, it's rounding
you're
it up.
saying-
It two's rounding up to be 3.
So you're saying if I owe you $2.99, it's $3?
Yes.
No.
That's just like if you go to the store and
That's
you.
not what this is, though.
No, it's actually saying it like that.
I want you to be completely 100% certain. I want you to be completely 100% certain this is absolutely correct. This is
Yes.
absolutely true.
That is-
2.9 repeat is 3. It's not close to 3.
It's
It's not close to 3. It is 3.
2.9 repeated.
No,
No,
it is
it
3.
is 3.
It is, and this is tough to get because of our base 10
So then-
system. It's tough for us
so then-
to finish it. I'll show it to you if you want to see it.
Wait a minute, can I ask you something? 2.8 repeated, so 2.8 repeated is 2.9?
No,
Why not?
because it's not.
Did you
It's
take
just not.
Couldn't you still round 2.8 up the 2.9? Couldn't you still round up to 2.8?
If you're rounding, but I'm not rounding here at all. I'm saying 2.9 repeating is 3.
No, it's not. You can explain this.
You can explain it to me, I'm still gonna, it's not, because it's a 9, and you don't have that little same.
You have a 3 and it equals
He said you don't have that
3
little
on the other
stick.
side.
Hey, now you're adding a plus sign, that's not what was.
2 plus 1 third.
Dealing with money,
Plus 1
this
third.
number is completely different.
Oh,
What are you doing?
What?
You want us to add this?
I'll add it in the calculator.
It's like, that's crazy, like you just figured out a new theory. No, that means 0.999.
You're telling me you're wrong. So I'm just,
I know why. It's like,
I'm just trying to present it to you.
I think I know why.
I did not come up with this.
Can I go? Alright, all those 3's together equals 0.999, right? Is that what that equals?
This,
If you add those
this
three
plus
up,
this plus
it's
this is
just
0.9 repeating.
But then if you put 3 over, that's going to equals 3 over 3, right? If you add those 3 up. So that's a whole 1.
I don't hear you. I don't hear you. You gotta slow down now.
Yeah.
Alright, put it back down.
So 3, that's going to 10?
0.9 repeating
It's
is
1.
1,
Right?
And why is
it's not approximately 1.
It's
It is
1.
1.
The 9 repeated is gonna make the 0 or 1.
So 2.9 repeated is basically 2 plus 1.
It's fun to put up on the board because it's like your brain is like, but it's not. It's really, really close, but it's not. But in fact, it is. It's because our number system is base 10. That's a very easy, simple explanation that our number system is base 10. Because what is 1/3?
1/3 is
As a decimal, what is 1/3?
0.3.
Yes, 0.3 repeating.
So why don't we put, we are putting, never mind.
Okay, so
I need some
when you put the 0.9, if it repeating equals 1, so basically 2.9 is basically 2 plus 1 equals 3.
Equals 0. Because every time putting 1/3 3, you're putting 0.
What's the question?
You get what I'm saying? You're putting 1 over 3, but then you're on the bottom you're putting 0.3, which technically that equals to the one on the top, right? So 1 over 3 equals 0.3 infinitely or whatever.
Wait, you're repeating
Right?
that.
And then 1 technically equals 0. I lost you. Let me backtrack real quick.
I hope you're not burning time.
No, I'm being serious. Like 1, you're putting 1 over 3, right? And then on the bottom you're putting 0 over 3. Because you're saying that equals each other. So then
Where do you see
0 over 3, what are you talking about?
I mean 0.3.
Yeah, 0.3 repeating is 1/3.
Oh, it is 1/3.
Yeah.
No, he's not.
Alright, so let's go back. Let's go back to the fact that division by 0 is undefined.
I agree with you. I don't
Okay.
want to be stuck on this all day.
So let's finish this problem. Have we finished this problem?
No, because it's wrong.
No, it's wrong. Right?
It's undefined, we can't.
Right, it is undefined. So what kind of solution is this?
No solution.
It's this here is we call an extraneous solution. So therefore, there is no solution to this. That's correct. There's no solution. A null set if you want to do that. Or you could write on a paper no solution. That's fine too. Isn't that cool looking? Yeah, I like that. If you know something, I know this.
How come up and down costs $1?
What's that?
How come up and down costs $1?
Don't do what?
We have like math discussions that we can.
I don't know. We're supposed to do some collaboration. You don't collaborate at all in your math class? In other math
Last
classes?
year, we would get onto a lesson, go over the homework, do the lesson, and we wouldn't actually spend a long time actually talking about it. So,
Okay.
Because we have time. In those classes,
Yeah,
we
100
stuffing in
108 days
material.
we got, don't we? 108 days?
Oh, no, I was other math classes. This one doesn't have any.
Miss Crane is out.
We got plenty of time. Why is it more?
You need to do what?
This is on the bottom of page 109. Guys, you need to tune back in if you're tuned out. This is on the bottom of page 109. If you have the text, if you don't have the text, I'm going to write it out. We have y sub 1 is equal to this, y sub 2 is equal to that. And it says to, I might have an answer. What is it?
Would you like us to write our text notes and bring it to class if we have one?
It's not a bad idea.
Okay.
But you know, with me, it may not be necessary because I'm explaining a lot verbally and I'm writing a lot in these videos I will be sharing in the near future.
Okay.
So it may not be necessary, but definitely it's nice to have at home. Because we got a book at home.
You want us to get out of books?
What's that?
When you want us to get out of books?
I thought I've been telling you guys, if you can get your book, go ahead and get it.
That's what so you take your book.
Just get your book. If there's any copies left.
I saw 3 people.
I'm tired.
Would anyone like to attempt this one?
It looks kind of confusing, but I'll take a whack
Okay,
at
so let's tune in. Let's tune in, guys. Let's tune in. Let's tune in. At 122, you can tune out. But let's tune in for 10 more minutes.
Wait, will you walk me through it if I do?
Yes. Y sub 1 is this. Y sub 2 is this. Find all values of x such that, or for which, y sub 1 equals y sub 2. Yes.
I can tell you the first step. You plug in.
Do you mind if he says the first step? I know you said you
No,
were
I'll do the rest. I'll just
Okay.
do the first
What do you think the first step is?
Y2 equals that, so you plug 22 over x squared minus 16 for all one.
Okay, yeah, exactly, because that's what it says. So let's go ahead and do that. Good job. So 22. Actually, I don't want to, a better way, I got to get used to doing this because I hate to take it away from you so quickly. So we have this. You guys can still kind of see that in the back. Okay. He said, let's go ahead and set their, since they are equal to one another, let's go ahead and substitute this for y sub 1 because it says find all values of x for which y sub 1 equals y sub 2. So let's go ahead and do that. So we're going to say 22, let's actually move this a little bit, move this out a little bit. This thing is so extreme here at the
Just
bottom.
press the button. You can
Because
press
if
the
it's, because
button.
if it's way huge, how crazy is it?
You can press the button. Press the button. Yeah.
Okay, thank you. So we have 22 over x squared minus 16 equals all this right-hand side here. 1 over x plus 4 plus 1 over x minus 4. Yes.
Oh, next step?
Sure.
Oh, x squared minus 16 is those two. If
Very
you
good.
split it up.
What is this called? Got a special name. The name makes sense. It's a difference of
2 squares.
There you go. Very good. So this is where again, and this needs to be in your notes. Factoring is a good thing. Factoring gives us information. Factoring allows us to change a sum or a difference into a product. X plus 4 times x minus 4. And if you want to verify that, you could go ahead and FOIL it, and you'll see x squared minus 4x plus 4x, 0x, minus 16. So it would become this. So now we're here.
This is that turtle do.
Okay. So now we're kind of at that one problem. We're kind of just like the other problem in the sense that, go ahead.
Okay, so what I was thinking is that now because we have a whole bunch of like terms we can cancel, all what we can do that thing we can slash or something, and we can go up and down.
Okay, I know you guys want to slash things.
Reduce to
I know you guys want to slash things, but what's the big picture, the big idea for going to the next? Because I don't like fractions. I'm assuming you guys don't like fractions. So the big picture is here. If I can eliminate all my fractions right now, that's what I want to do.
You can eliminate the right side, right?
Yeah.
I want all my fractions gone.
So
I want so there's no longer any denominator except technically one.
I
They cancel all the denominators.
But how do they cancel? This is the thing I want you guys to like get, like how they, and it's
You
not really
gotta divide.
canceling, but they go to one. How do they go to one? Yes,
Multiply it by x plus 4. Or no,
you multiply.
X plus 4, X minus 4.
First off, you have to multiply both sides, right?
Both sides,
You have to
yeah.
both. What? Yes. Which is
Divided by x plus 4 x minus 4.
divide by,
no multiply.
multiply by. Yes, we're going to multiply both sides by this whole product here. Because notice this whole product. First off, it is this guy's denominator, but it would also be enough to cover each of these. Okay, it's got to work for all of them. I mean, you could do one at a time, but you'd find out, wow, it would have been a lot quicker if I just multiplied right now, all in one step, the whole product of x plus 4, x minus 4. I'm going to erase a little bit here so I have room to show that I'm doing that.
Mess it up.
And I'm going to move this guy over a little bit because I want to write blue on blue.
Okay.
Ah, here it is. No, no,
Yeah, that's good.
no, that's not what I want. I want you to be clear here. Clear notes. Okay, so we're going to multiply. And of course, I didn't give myself enough room here. That was kind of silly. Let's go. Right now. We're going to multiply this side and this side by what we said, this whole thing right here. X plus 4, x minus 4. I'm sorry to write on the blue.
Okay.
Over here, we're going to multiply, I hate that I'm out of the room, x plus 4, x minus 4. I know it's really badly written, but I'm saying enough, x plus 4, x minus 4. So what happens, what do we get?
22
Uh-huh.
times
1 plus 1.
1x plus 4, because you're multiplying that whole side.
Imagine this is being distributed to this guy.
Wait, so.
What would go away to 1 and 1?
The denominators.
The x plus 4 would go, this x plus 4 would go, because remember, this is like over 1.
Uh-huh.
Notice the x plus 4 and x plus 4 would go away to 1 and 1.
You can cross them out.
Well, okay, I'll do it. So I'll cross this here and this here, leaving you x minus 4 times 1 over 1 times 1.
What?
Okay,
Okay.
this here is back to this basic principle here. That's what's going on here.
Okay.
Once
Even if
we
it's-
get y though, once we get y, we do it, can't we just,
Why are you
Simply cancel it all
leaving
out.
the other?
Once we do what?
once we get y though, can't we just cancel it all out?
Once we get y.
Yeah, like you were saying, you were explaining why we do
No, that one,
instead of just taking the
that one just like we said, those are two separate.
No, but let's definitely get this right. That this is not just 1. This is going to be x minus 4.
Well, don't the x minus 4 is canceled out?
There's nothing to cancel. This is the only thing that exists is the x plus 4 for this guy. Now we're going to do this guy plus distribute it to this guy. Don't forget the distributor property, guys. Don't forget this. If I have something like this, b plus c plus d, I have to distribute this to each guy, the distributor property. It's going to be, if I say this, it's going to be ab plus ac plus ad, right? We have to distribute. We have to distribute.
So what you just did, what you distributed the x,
I just don't have a lot of room. It's just a lot of writing to show, but I'm just imagining I'm distributing here. These would go away, leaving me x minus 4. And if I multiply this guy, because I also have to distribute to this guy because it's separated by addition, the x minus 4s would go away, leaving me x plus 4.
I definitely think I just got you.
I definitely do.
No, I
got you. Okay, so what you did
The
was
plus
I
sign
don't
like
understand
confused
Why
me.
you didn't
Or
like?
like I didn't see that, because you're doing that is because of the plus sign, correct? So
Yeah,
why
yeah.
you're not multiplying when it's the 22 and all towards it? It's because those two bottoms aren't, they don't have x minus y.
This whole thing.
Yeah.
this way, yeah.
It's fraction.
This one time is like x minus 4 over 1 times 1, right? Okay, wait, I have a question. I'm over here talking to myself, make sure I got it. So, okay, right here. So, for the right bracket.
I apologize if the bell cut you off, but go ahead.
Okay, so you did 1 times x minus 4 times 1, right?
For here,
Yes.
1 times x minus 4 all over 1 times 1.
Yeah. So that's how that is made to x minus 1.
X minus 4.
That's dead, that's what I meant. 22 x minus 4. But how did you get x plus 4 for this group?
Because what we cancel here is the x minus 4 and the x minus 4, leaving you with x plus 4.
All over 1 times 1. Okay. Thank
Yeah.
you.
all this is in the book, right?
Do you see him?
I believe they do work this one out. This one is worked out.
Just add the book, and I'll check on that.
I don't believe this one is actually worked out. This one's not worked out, so you have to get it from. We can go over this one again if you guys want to.
That's just like,
And what I'll do is I'll show each step, like every single little step.
there you
And that's all I have to
go.
do.
That's what
And that's what I'll do. That's what I'll do. Y'all